Hello, this is Nick Andre. Welcome into another screencast. In this screencast, we'll explore Cisco's Inter-Network Operating System and examine the basic configuration process used by Cisco devices. Similar to a personal computer, a router or switch cannot function without an operating system. Cisco's iOS is the core technology that extends across most of the Cisco product line. The services provided by the Cisco operating system are generally accessed using a command line interface, or CLI for short. The features accessible through the CLI vary based on the version of the operating system and the type of device. A typical iOS device can handle routing and switching, address interfaces, and secure networked resources. These features, as well as the operating system, are stored on a non-volatile component called flash memory. To increase performance, most devices will load the operating system into RAM when the device is starting up. Using flash memory allows the iOS to be upgraded to newer versions or to have new features added. When a router is first placed into service, networking parameters have not yet been configured. Therefore, the router cannot communicate through a network. Configuration commands for setting up the router can be issued via the command line interface. You can access the CLI environment in several ways. The most common methods are through the console or auxiliary ports, as well as active interfaces by way of the network services like Telnet or SS. To prepare for the initial startup and configuration, a computer running terminal emulation software is connected to the console port of the device. The console port, also known as the CTY line, is used to make the initial configuration file or access the device when the networking services have not been started or have failed. In case this port should fail, a network administrator can use the auxiliary port as another console port. To access the console port, you must be physically near the device and use a special cable known as a rollover or a console cable to connect your terminal directly to the iOS. Since this port can recover passwords, it is highly recommended that the device be placed in a locked room or equipment rack. The other methods can be used to access the CLI remotely through a dial-up connection or a telnet session. To establish a CLI session remotely via a telephone dial-up connection, a modem must be connected to the auxiliary port. Similar to the console connection, this method does not require networking services to be configured or installed on the device. Generally, the only time the auxiliary port is in use is when there are problems with the other methods. A method for remotely accessing a CLI session is to telnet the device. Unlike the console or auxiliary connection, telnet and SSH sessions require active networking services on the device and at least one active interface configured with a layer 3 address. Secure Shell, or SSH for short, provides the structure for remote login similar to telnet, except that it encrypts the session data being passed around. A VTY session, or virtual teletype interface like telnet, requires a password as a minimum authentication method to create a remote session. Configuration files contain the software commands used to customize the device. There are generally two configuration files for an iOS device: the startup and running config files. The startup configuration file is used during system startup to configure the device. Because the file is stored in NVRAM, when a Cisco device is turned off, the file remains intact. The startup config file is loaded into RAM each time the router is reloaded or restarted. After it is in RAM, the startup configuration file becomes the running configuration file. The running configuration file is used to operate the network device. Changes to the running configuration will immediately affect the operation of the device. After making any changes, the administrator should save them to the startup configuration file so that they will be used the next time the device restarts. The Cisco iOS is designed as a modal operating system. The term modal describes a system where there are different modes of operation, each having its own domain of operation. The CLI uses a hierarchical structure for the modes. Under a hierarchical modal structure, each mode can be configured with different authentication credentials to control the level of access. Each mode is used to accomplish particular tasks, hence only commands that are appropriate for that mode are allowed. From top to bottom, the major modes are as follows: the user exec mode, a mode that is very limited in scope, allowing basically only viewing types of iOS commands. The Privileged Executive or Enable mode. Like an administrator in Windows, this mode allows users to access the entire iOS command structure. The Global Configuration mode. Commands executed in this mode apply to the entire router. And other specific configuration modes. Commands executed under these interface modes, for example, would apply only to that particular interface. The prompt is composed of the device name followed by the mode indicator. As commands are used and modes are changed, the prompt changes to reflect the current context. To distinguish each mode, Cisco's iOS uses a distinct prompt. The user exec mode is often referred to as a view-only mode and by default does not require authentication. This mode is identified by the device host name followed by the greater than symbol. In this case, our device has a host name of router and the ping command is executed from the user exec mode. The next prompt would indicate that the user has changed from user exec to privilege exec mode. Notice the greater than symbol was replaced by the pound symbol. This mode is often referred to the enable mode because the enable command is used to escalate the user's privilege. To enter the commands that will change the router's configuration file, the user must be at least in the global configuration mode. This mode can be identified by the word config surrounded by parentheses between the host name and the pound symbol. There are many different submodes that can be found under the global configuration mode. In this example, the user will assign an IP address to the fast Ethernet interface. Notice the prompt reads router parentheses config dash if parenthesis pound symbol. That's because the changes that are being made for this particular interface must occur in real time, i.e. running config to a specific component, hence the submode interface. Each iOS command has a specific format or syntax and is executed at the appropriate prompt. The commands are not case sensitive. The general syntax for a command is the command followed by an appropriate keyword and or argument. For example, in the following syntax, the show command is followed by the keyword IP with another keyword protocols. An argument is not a predefined word. Like in this example, we have the command ping followed by an argument of 192.168.10.5. This argument could vary according to the network configuration. Usually bold-faced text indicates commands and keywords, and italicized text is used to indicate arguments. To help with the command syntax, Cisco's iOS has several forms of aids available, including hotkeys, command syntax check, and context-sensitive help. The context-sensitive help provides a list of commands and the arguments associated with those commands within the context of the current mode. To access context-sensitive help, enter a question mark at any prompt or after a command. In this example, the user illustrates a classic technique of using the help menu on the fly. We start off typing CL. Not sure what's after, so I hit the question mark. The iOS displays the command that begins with CL. So I type in clock, space, and a question mark to display a list of keywords and arguments. The only keyword for the clock command is set. So I type clock, space, set, and hit enter. The iOS command syntax checks informs me that the command was incomplete. To find out what is missing, I type clock, set, space, question mark. This time, I need to supply the clock set command with the current time. However, the command syntax check and context-sensitive aids inform me that I am missing date information. Retyping clock, set, current time, and date, the command syntax checks and tells me that 6 is not appropriate. In order for me to finish the command correctly, I have to type in June, followed by the year, and then I hit enter. Once again, this is a classic example of using the context-sensitive help menu on the fly, as well as the command syntax check. Here are a list of a few of my favorite keystrokes. The tab key helps to auto-complete a command after the user types a few keys. In this example, I started to type SH. Instead of typing in SHO, I type SH and hit the tab key to auto-complete this command. This technique even works with keywords. Another favorite is the Control-Shift-6 hotkey, used to break an iOS process such as ping, traceroute, or DNS lookup. To interpret the output and interact with the CLI, all a user simply has to do is press and hold the Control-Shift key, hit the number 6, and then hit the X key. For more hotkeys and shortcuts, visit the link at the bottom of the screen. To verify and troubleshoot network operations, you must examine the device configuration. The basic examination command is the show command. The show command has many different variations. Use the show ? Command to get a list of all the available commands in a given context or mode. The show interface command displays a stats for all interfaces on the device. This is helpful and can be used to determine if the router has experienced any input or output errors. I personally like to use the show IP interface brief command to get a quick summary of the interfaces and their operational state. A network administrator can use the show startup config or show running config to check the router's configuration files. The show running config displays the contents of the current running configuration file or active settings. The show startup config will display the saved configuration located in NVRAM. You are now ready to examine some of the basic Cisco iOS commands used to create configuration files on both Cisco routers and switches. The following sections provide you with the knowledge to apply device names to Cisco devices, manage access with the use of passwords and banners, manage configuration files, and configure device interfaces. To access this router's command line interface, I must join my end device to the router's console port. To do that using Packet Tracer, I'm going to come down to my connection tools, and I'm going to click on the very first Aqua Arc. If I hover over the button with the Aqua Arc line in it, it'll say console. So let me click on that, and then I'm going to click on the PC0. Now, when you have a real-life console cable in your hand, you'll notice one end looks like an Ethernet end, and the other end looks like a serial port end. When it comes to Packet Tracer, they call their serial port an RS-232. So in order for me to connect the PC to my router using the initial configuration port, that is the console port, I must connect the console cable to the RS-232 of my end device, and then I'm going to click on the router and connect to the console port of the router. After I click on that, I'm going to open up my PC, click on the desktop tab, and then I'm going to launch the terminal software. These are the default settings that work with Cisco routers. I need 9600 bits per second, I need 8 bits to represent a letter, and then I need 1 stop bit. So there we are. Let's click OK. And then I am given a prompt about walking through a configuration dialog or a wizard. I'm just going to type in no and then hit return. Now I am greeted with the user exec mode. The enable and disable commands are used to change the CLI between the user exec mode and the privilege exec mode respectively. Here you can tell that I am in the user exec mode because my prompt reads router followed by a greater than symbol. If I want to escalate my user privilege mode, all I need to do is type in enable and then hit the enter key. Since this is the first time I'm setting up this router, I am not greeted with a password authentication prompt. Instead, I am greeted with the router followed by a pound symbol. The pound symbol is used to indicate that the user is now in privilege exec mode. To get back to the user exec mode, all I need to do is type in disable, or I could type in exit. Either or would work. So to get back to privilege exec mode, just type in enable. To get back to user exec mode, just type in disable. When you are naming devices, names should follow these conventions. First, start with the letter. Doesn't contain any spaces. Has characters of only letters, digits, and dashes. And the name is less than 64 credits. To give this device a name, I need to first escalate my privileges. So let me type enable. And then I need to go to the global configuration mode. To get to the global configuration mode from here, I'm going to type in config, hit the tab key because it's one of the shortcuts I've learned in the previous slide. Type in T and then hit the tab key to autocomplete terminal and let me hit enter. Now I'm going to type in host, hit the tab key, have it autocomplete host name, and then I'm going to call this router R-1. I begin with the letter. It contains no spaces and it's less than 63 characters. So let me hit enter. And that's it. As you can see, my prompt has changed from router to router-1 config because I'm still in the global configuration mode, followed by a pound symbol because my privileges are escalated. To restore the device host name back to its default value, I can simply type in no space host name after the configuration prompt. And as you can see, it clears out the R-1 and returns it back to router. Banners can be an important part of the legal process in the event that somebody is prosecuted for breaking into a device. Some legal systems do not allow prosecution or even the monitoring of users unless a notification is visible. The banner should detail that only authorized personnel are allowed to access the device. The banner can include scheduled system shutdowns and other information that affect other network users. It should never welcome somebody to the router. Proving liability would be difficult if there is an appearance of an invitation. To configure the message of the day from the user exec mode, I must first enable my privileges, then go to the configuration terminal, and then type in banner MOTD space some terminating character. So in this case, I'm going to use the pound symbol and then hit enter. When I do this, I'm asked to enter in a text message for the message of the day. The text message is the argument for the MOTD keyword. Remember, the message of the day could be used for the legal process in the event that someone is being prosecuted for breaking into this device. So I'm going to supply the message of the day with the following text. Now that I'm done with this message, I'm going to, after these wildcards, put that same pound symbol that I started the message with. This is sort of like an identifier for the command banner so that it know when the message begins and when the message or where the message ends. So let me hit enter, and now I'm back to my prompt. To view this message of the day, I can do it in several ways. I can type in exit, hit enter, and then I could type in disable. Because remember, this is the message of the day. So in order to see it, it's the first time I log into the router. So let me type in exit from the user exec prompt, and then let me hit enter, and there I am greeted with the message of the day. The other place I can see it is in my configuration file, and I can see it by typing in show running config, but we're going to learn that later on in this screencast. Physically limiting access to a network device with closets and locked racks is a good practice. However, passwords are the primary defense against unauthorized access to a network device. As good practice, use different authentication passwords for each of these levels of access. Additionally, use strong passwords that are not easily guessed, and the following points should be considered. Passwords with more than 8 characters in length, combinations of upper and lower case and/or numeric symbols. Avoid using the same password for all devices, and avoid using common words such as password, administrator, admin, and etc. To set up the console password, I need to change my mode to privilege exec mode. To do so, I'm just going to type in EN, the abbreviation for enable, and hit enter. I must be in global configuration, so I'm just going to type in config space T. Once again, I'm using abbreviation to access these modes. Now, in order to set up the console password, I need to be in a specific mode. So I'm going to type in line space console because it's dealing with a particular interface or a port on my router. Now I'm only going to type in line console 0 because my particular router, the 1841, only has one console port, console 0. So let me hit enter, and then I'm going to type in password, which is the actual command to issue a password, and after that it's going to require an argument. In this case, I'm just going to type in Cisco. I know this isn't a strong password, but this is just for demonstration purposes only, and I'm going to hit enter. Unfortunately, this does not tell Cisco when to ask for the password. So in order for the console password to be enabled, if you will, I need to issue the login command. So it says, hey, for now on, anybody who wants to log into my router, they must authenticate and they need to supply me with the following password. That is the Cisco password. To illustrate this in effect, I'm going to hold the control key and hit the letter Z. What that's going to do is going to X me out of global configuration and bring me right back to the privilege exec prompt. As you can see, I have router followed by the pound symbol to let me know what prompt I'm in. I'm going to type in exit, and now I'm back out of the router as if I'm just starting to sign in. If I hit enter, I am greeted with the message of the day as well as a prompt for the password. Since I am logging in through the console port, here it is saying, hey, sorry, user access verification. So let me type in Cisco because that is the password that we set up. You notice when I type in Cisco, the characters do not appear. This is just a safety mechanism in case somebody's overlooking my shoulder. The enable password or the enable secret command provides additional security. Either of these commands can be used to establish authentication before accessing privilege exec mode. The enable secret command provides greater security because the password is encrypted. If no enable password or enable secret password is set, the iOS prevents privilege access from a telnet session. To set up the enable password, one simply needs to elevate the privilege. So let me type in EN, and then go to the global configuration mode. So let me type in config space T, and then simply supply enable space password, and then the secret password afterwards. So in this case, I'm just going to type in class and hit enter. If you want to encrypt the password, then the best choice to do is type in enable space secret and then the password you would like to have the user enter in. In this case, I'm just going to type in class again and hit enter. Once again, the enable secret automatically encrypts the password to give you better security than just simply the enable password. VTY lines allow access to a router through Telnet. By default, many Cisco devices support 5 VTY lines that are numbered 0 to 4. A password needs to be set for all available VTY lines. By default, the iOS includes the login command on VTY lines. This prevents Telnet access to the device without first requiring authentication. To set up a VTY line, one has to simply escalate the privileges. As you can see, once again my router has booted me off, and now I need to log back in. So I'm going to type in Cisco for my password because I'm logging in via the console cable, and I'm back at user privilege mode, and I need to type in enable to change my privileges, and once again it's going to ask me for a password. This was the enable secret password that I set up in the previous slide. So let me type in I believe it was class for the password, and now I'm at privilege mode. So let me go into global configuration. And setting up VTY password is very similar to setting up a console password. One must just type in line space, instead of console we're going to type in VTY, then a space 0, then a space 4. What I'm doing is setting up the same password for all 5 of my connections. So let me hit enter, and I'm going to type in password, and I'll use the same password. I know it's not good to use the same password for every line, for every devices, but once again this is for demonstration purposes. So let me type in password Cisco and let me hit enter. Now I know by default the login command is already issued for VTY, but I like to be thorough, so I'm going to type in login again just like I would for a console cable. Let me type in exit to get out of that particular mode, and let me type in exit again to get out of global configuration mode. Now I'm back to the privilege exec mode. Another useful command prevents passwords from showing up as plain text when viewing the configuration files. To demonstrate this, I'm going to execute the show running config command before turning on the password encryption service. The unencrypted passwords should be visible. Then I'll turn the service on and display the running configuration file again to see what the service has done to the router. So to begin, I'm just going to type in show, run, and then hit the tab key, and it's going to auto-complete to running configuration. Hit enter, and here you can see that the enable password class is clearly red, but the enable secret is not. It's gargled up using an MD5 encryption mechanism. Up above under version 12.4 you can see that no service password encryption is actually turned off. So translation, it reads service password encryption turned off because the word no in front of it's telling it to turn it off. Now I am prompt with the more prompt. In order to see more of the file, if you will, I can hit the space bar, and that's going to jump down to the next page, or I can hit the enter key to do line by line. I prefer hitting the space bar just to page through this rather quickly. I'm back to the privilege prompt because it reads router followed by a pound symbol. Remember, with the CLI, the screen is being shared for both input and output. So pay attention to your prompts. When it reads more, it just is telling you that there's more to the file. In order for you to see it on your screen, just hit the space bar or the enter key. Either or will have you page down. One will do it line by line, the other one by groups of lines, if you will. Alright, now that I showed you that the passwords are actually unencrypted, let me go and turn the service on. To turn the service on, I must be in global configuration. So let me type in config T, and now I'm going to type in service followed by password, and I'm just going to type in pass and hit the tab key, easy on the fingers, and let me hit enter. Remember, the CLI doesn't pat you on the back when you do something right. It only yells at you when you do something wrong. So far it seems to be doing just fine. Now let me exit out of the global configuration and type in show space run, hit the tab key, and hit enter. This time you can see that the enable password is actually encrypted, whereas before you could read the password. Once you turn the service on and you go to turn it off, let me illustrate this. So let me hit the Q key to get out of this and type in config T and type in no service password, hit enter, type in exit, and go back to show run config. You will see that if you turn it on and then turn it off, the passwords that were encrypted will stay encrypted, and any new passwords that you go to set up now will be back to plain text. It is good philosophy or good technique to actually leave the service running. So let me type in config T and type in service followed by pass and then hit the tab key, and now we're back and running. Modifying a running configuration affects the operation of the device immediately. The following sections explore some commands designed to manage the configuration files. Remember, because the running configuration is stored in RAM, it is temporarily active while the Cisco device is running. If power to the router is lost, or if the router is restarted, all configuration changes will be lost unless they have been saved. Before committing to the changes, use the appropriate show command to verify the device operation. When the changes are verified to be correct, use the copy run start command. To do this, let me make sure that I am in privilege mode. I see it reads router followed by a pound symbol. Now I'm going to type in show space run and hit the tab key. I did this in the earlier slide just to illustrate that the passwords were being encrypted. Now I'm going to go through this line by line to verify that all the stuff I have done, like host name, router, service, password encryption, are being actively involved in this device. Let me hit the space key to go down to the next page. I see I haven't set up my interfaces. Let me hit the space key. I see that my banner, the message of the day, has been configured. It is actively running on this router. I also see that my passwords for the console and the VTY are both set up and are encrypted. Let me hit the spacebar, and I reach the end of the configuration file. These are all things I'd like to keep, so if the router does have to be reloaded, it'll boot up with the startup configuration file. To do this, I'm going to type in copy, space, run, and hit the tab key. Then I'm going to type in start and hit the tab key. Now you could use abbreviations and just simply type in copy run start and all should go well. Now the operating system's asking me, is the destination file named startup-config? This is important because now it knows to modify or create the startup configuration file in NVRAM, which is non-volatile. So let me hit enter, and it says OK. Now I can type in show space start, hit the tab key, and it's going to autocomplete the startup config, and hit enter, and it's going to be identical to the running configuration file because it just copied the running configuration into the startup configuration file, and I haven't made any changes to the router's active configuration file. So if I page down through this, everything should be exactly the same line by line. And as you can see, that was the case. If the changes made to the running configuration do not have the desired effect, it might become necessary to restore the device to its previous configuration. Assuming that you have not overwritten the startup configuration with the changes, you can replace the running configuration file with the startup configuration file with the reload command. Now this command must be typed in from the privilege exec mode. Unfortunately, when I type in the reload command, it's not going to have the desired effect of restarting the router back to normal because I just got done saving my running configuration into my startup configuration. But it is a good lesson to actually see the router reboot as it's self-decompressing the operating system and loading it into RAM. So this is going to take a few seconds. It's going to actually now grab from the startup configuration file, and I will no longer be presented with would you like to go with the configuration dialog box. So let me hit enter, and I should see the message of the day, which I do, and I'm asked for that password. So let me type in Cisco, and now I'm in. If undesired changes are saved to the startup configuration, it might be necessary to clear all the configurations. This requires erasing the startup configuration and restarting the device. Exercise care when using the erase command. This command can be used to erase any file on the device. Improper use of the command can erase the iOS itself or its critical files. To erase the startup file, I'm going to escalate my privileges. So let me type in EN, hit enter, and then I'm going to type in my password. And then I'm going to type in ER and hit the tab key. And then I'm going to type in start and hit the tab key. And then I'm going to hit enter. It's going to ask me if I'm sure if I'm going to do this, because when I do this, I'm going to delete the NVRAM startup file, and when the router reboots, it's going to reboot back to factory default, asking me to reset everything up. In this case, I'm illustrating how to clear out a router and start fresh from the beginning. So I'm going to hit enter, and then I'm going to type in reload. So the router will be forced to start over from again. So let me hit confirm by hitting enter. And now the router is self-loading up, and I will be greeted this time with the configuration dialog box. And I'm going to type in no like I did the last time I was greeted with this message. So here I am. Would you like to use the configuration dialog box? Let me type in no and hit enter. And you can see the message of the day is gone. I hit enter to begin, and I'm greeted with the user exec mode. Throughout this screencast, you have learned about commands that are generic to iOS devices. Some configurations are specific to a type of device. One such configuration is the configuration of an interface on a router. Because the purpose of a router is to interconnect different networks, each interface on a router has its own unique IPv4 address. The address assigned to each interface is part of the network's address range of the network segment connected to that interface. The following sections discuss the most basic interface commands. Router Ethernet interfaces are used as the gateways for the end devices on the local area networks directly connected to the router. Each Ethernet interface must have an IP address and a subnet mask to route IP packets. To set up an Ethernet interface, one must change their user mode to privilege, so let me type in enable, hit enter, and then arrive at the global configuration by typing in config T, and then entering into a specific mode. In this case, we are going to be configuring an Ethernet interface, so I'm going to type in int and then hit the tab key. INT is just short for interface, and then I'm going to type in FA and hit the tab key. Because I'm configuring one of the fast Ethernet ports, I'm going to begin by typing in FA, short for fast Ethernet, hit the tab key. Now the 1841 routers have two Ethernet, fast Ethernet interfaces hardwired into the motherboard. One's going to be 0/0 and the other one's going to be 0/1. In this demonstration, it doesn't really matter which one I'm going to configure, but in the real world, the one you're going to configure is the one that you plan on implementing for that particular network. So let me hit enter. Now to set this up, I'm going to give it an IP address. To do this, I'm going to type in IP space address, hit the tab key so it auto completes for me. And let's just say, for an example, that this fast Ethernet is the gateway for a network that begins with 192.168.1. And I'm going to assign it the last usable address. So I'm going to put a .254, and the subnet mask for this network is 255.255.255.0. So the arguments for the IP address command first set is going to be the IP address followed by the net mask. Let me hit enter, and now let me type in no shut. It's really critical to type in the word no shut. No shut short for no shutdown. In other words, leave this interface on or turn it on. So let me type in no shut, hit enter, and as you can see, my interface has gave me some feedback saying, oh, I changed my state to on. Let me hit enter. And now let me also give this a description just to help me for later to know what this interface was connected to. So let me type in DES and hit the tab key. And then I'm just going to type in connects to local area network 192.168.1.0. Now you might say connects to the Dallas network or connects to my home network. To each is their own. The description is not really necessary to configure an interface. It's just used for later when you forget what the interface is actually representing or connecting to. Let me hit enter. And now let me hold the control key and hit the letter Z to exit out of the global configuration and arrive back to the privilege exec mode. I love that control Z. It's just a nice shortcut to exit back to privilege mode. Now here I am at privilege mode, but this time I'm going to type in show IP interface brief. I told you earlier that this is one of my favorite commands to see what the parameters are for my interfaces. So let me hit enter, and now I can see that the fast Ethernet 0/0 is properly configured. I have a 192.168.1.254 address. It says the interface is properly working because there's a yes under the OK. It was manually assigned because I'm the one that gave it the IP address, and the status is up, but the protocol is down. The reason why the protocol is down is because I haven't plugged a cable into this interface card yet. Serial interfaces are used to connect WANs to routers at a remote site or ISP's office. Each connected serial interface, just like an Ethernet interface, must have an IP address and subnet mask to route IP packets. Serial interfaces require a clock signal to control the timing of the communications. On serial links that are directly interconnected, as in a lab environment, one side must operate as a DCE to provide a clock signal. The clock is enabled and the speed is specified with the clock rate command. Just remember, only one side is to be the DCE and the other end is set to be the DTE. The clock rate command is only issued to the DCE end of the serial cable. So, to configure a serial interface, I must be in the global configuration. Let me type in config space T. And this time I'm going to type in INT, hit the tab key, but the letter S, short for serial, let me hit the tab, then 0/0/0. In order to add a serial interface to a router, you must turn it off and plug in a serial interface card. In this case, you see I have 3 additional zeros. I have a 0/0/0. One 0 indicates the slot, the other 0 indicates the card, and then the last 0 indicates the port or the interface. Let me hit enter, and now I'm going to do the same thing I did for my fast Ethernet. I'm going to type in IP space address, and then I'm going to give it an IP address. Let's say this one's 1.2.3.4 space 255.0.0.0. I know this is ridiculous. If it's a serial connection, you'll probably use 255.255.255.252. This is just a demonstration to show you that the same parameters are being used to configure a serial interface as there would be to configure the fast Ethernet. Let me hit enter, and just like before, I can type in no shut to turn on the interface. And just like before, I can give it a description, and I'll just say the WAN side of the router. Now obviously you'd give it a better description of the router, and let me hit enter. The only difference is on this interface I must set up a clock rate, because I'm telling the other router that I'm going to be the DCE. To set up the clock rate, I'm just going to type in clock space rate, and then I'm going to give a number. I'm not sure what values I could put in here, so I'm going to type in the question mark, and the iOS is going to give me a display of popular values that it would accept. So let me type in 64,000 and hit enter. Let me hold the control key, hit the letter Z to go back into privilege mode, and let me type in show IP interface brief to see if the serial 0/0/0 is up and running. By the way, you can also use this command to display all the interfaces that the router has plugged into it. As you can see, I have a fast Ethernet 0/1, and I also have a serial 0/0/1 that have yet to be assigned. And just like before, the interface is administratively up because I said no shut, but it's represented as down because I don't have another DTE connected to the serial, so the router chooses to turn it off, not to include it in the routing table, and the protocol is down because there is no cable connected to it. Now if this was the DTE side, the other router is going to connect to this serial interface, I would not issue the clock rate command. A LAN switch is an intermediary device that interconnects segments within a network. Therefore, the physical interface on the switch do not have IP addresses. To be able to manage the switch via Telnet, the switch must be assigned an address. The address for a switch is assigned to a virtual interface represented as a VLAN or virtual LAN. You assign an IP address to this VLAN 1 interface to be able to access it via a Telnet session. To do this, let me come down here to the lower left corner, grab a switch, and drop it on my topology. To configure the switch, I'm going to disconnect the console cable from the router and plug it into the switch. To do this, I need to first delete it. Come down here to my lightning bolt, choose the Aqua Arc, click on PC0, choose the RS232, and then click on Switch and choose Console. And just like before, I'm going to click on PC0, click on the Desktop tab, click on Terminal, and then click OK. Let me maximize this so it's the only thing I see, and let me hit enter to begin this. Alright, so we need to set up a virtual interface. To do this, I'm going to change my mode, so I'm in privileged exec mode, so let me type in enable. Notice I only have password set up, so it's not going to ask me for anything like that. And now I'm going to type in config t, and now let me type in int, but this time I'm going to type in VLAN 1. And you can see my prompt is read just like it was read before in the router. This time it says switch config-if, short for configuration interface, and let me type in IP space address. Remember, by doing it this way, I'm assigning the whole switch an IP address, and I believe we were using the 192.168.1 network address, so let me put in a .253 because my router was 254, and let me put a space and type in 255.255.255.0 and let me hit enter. Now I don't have to type in no shut because this is a virtual interface and it should be up anyway, but I like to be thorough and I'm going to type in no shut to begin with. And now let me type in exit. Now this switch can now be configured by any local device. What if I want to configure the switch to be configured remotely from some other device outside my network? To do this, I need to make sure I'm in global configuration. So I typed in exit and I hit enter. Now I'm going to type in the word IP space DEF and hit the tab key. The reason why I need to type in IP is because my default gateway is using an IP addressing scheme and not some other layer 3 addressing. So I typed in IP space default gateway space, and now I'm going to type in the IP address of my router, which was 192.168.1.254. Remember, this is going to be used by the switch for remote access, so other people outside my network can gain access to Telnet to help me troubleshoot or configure my switch for me. So let me hit enter. And just like that, I have set up my switch so that it can be accessed remotely. In this screencast, we learned the basic configuration process used to configure Cisco devices. I included a document with this video to help you create your own topology using Packet Tracer and practice Cisco's iOS commands. This was another screencast brought to you by Nick Andre, your at-home instructor. For more screencasts and/or videos, please visit my YouTube channel. Thank you for your time, and I'll see you in the next screencast.